ReasonConf is brought to you by our gold sponsors Ahrefs and Chain Street.
Yeah, thanks for the introduction. My name is Christoph. I'm the CTO at CCA.io. The theme of this the theme of this conference is on the road to production. And today I would like to show you a Reason app that we put into production in 2018. And it's an enterprise web application for the domain of railway safety. First of all, a few words about who we are and what we do. So CCA is an Austrian company based here in Vienna. It was founded in 2013 as a spin-off of Frequentis AG. We focus on the domains of public transport, public safety, and industry, and build mobile solutions and cloud-based services for our clients. And for these applications, correctness and robustness are of very high importance. Let me show what our front-end development stack looked like in 2017. So we were using React and React Native and a bunch of other tools that you may have seen somewhere. And we were happy with React and React Native, and we were shipping software successfully with this stack, but there were quite a few things that we were not 100% satisfied about, like Flow taking 90 seconds to start up in one of our projects. But this could be the subject of another full-length talk. So for now, let me just say that we tried out Reason, and we got hooked. And so our 2018 stack looked like this, much simpler and much more reasonable. And things turned out well. By the end of that year, we had already delivered several Reason apps, both web apps and React Native apps. And one of these apps is the written order app that I'm going to talk about today. So first of all, a quick overview of this talk. I will talk about what a written order actually is. Then the ideas behind the written order app. I'll give you a live demonstration. After that, I will explain which libraries and tools we use to build the app, in addition to the somewhat trimmed down stack. And last, I will share with you the feedback that we received from our customer and from our developers. So let's delve into railway safety. What is a written order? Usually, train traffic in Europe is managed by automatic signaling systems. But there are some special situations where a signaler needs to manually give permission for the train to proceed. So what are some examples for such situations? In the first situation, there is some kind of infrastructure failure. So the signal that you see here is red, although it should actually be green. So someone must give permission for the train to proceed in spite of the red signal. In the second situation, the driver passed a stop signal because he overlooked it or because he was not able to stop in time. And in this case, an automatic emergency stop is triggered by the train control system, and still a manual decision must be made on how to proceed. In the third situation, the train is already standing behind the signal, for example, due to a shunting maneuver. So what all three situations have in common, someone must give manual permission to go on. And there's a process for that. The process is a phone and paper-based one. It goes like this. First of all, the train driver picks up his GSM-R phone and calls the signaler. Now the train driver needs to describe the situation he faces and also the current position of the train, because there's no automatic way for the signaler to know the current position. Now the signaler needs to assess that situation. He needs to perform a lot of checks manually that would normally be performed automatically by the signaling system. And when he has come to a decision about the correct course of action, he must document it in the so-called written order form. So it's a paper document. You can see it in the background of the slide, actually. Let me bring it to the foreground for a moment. So this is part of a French written order form. And when he has completed the form, the signaler calls back the driver, reads out the order to him. The driver must confirm that he understood everything correctly. And again, there's some paper-based process or some kind of offline process through which the signaler obtains an authorization number that he also needs to note to the form and pass on to the driver. And now the driver is authorized to continue the journey of the train, and the written order form is archived, and this process is completed. So in this process, we have seen the signaler has a lot of responsibility and a lot of things to care about. The correct course of action depends on many parameters and requires exhaustive knowledge on the railway infrastructure. So how can we support the signaler in this process? And this is where our written order app comes in. So the idea behind the written order app is to have something like an intelligent agent for the signaler, an intelligent assistant. And the responsibility always remains with the signaler. So it's not our system that makes the decision. Our system just helps the signaler in the process. So it presents the signaler checklist, a series of questions to answer. And these questions are highly contextual. They depend on the situation, the topology, and the previously given replies. And the system provides all this contextual information to the signaler and ensures that he considers all relevant aspects. But these checklists are not hard-coded in our application. In fact, there is a checklist programming language, so in which our customer or we, on setup of the system, can configure completely freely how these checklists look like. And the application executes these checklists, as you will see later. Yeah, so now for the live demonstration. Let me just fire up Chrome. Oh, wait, that would be too easy. Actually, our customers have one thing in common. Mostly, they love for a common browser, and that is Internet Explorer. So I'll bring up a VM of a Windows VM with Internet Explorer 11. Yeah, give me a moment to switch the screen accordingly. So I'm firing up Internet Explorer. The application should be in the cache. Ah, now we're there. Okay. We have internet connection. So, okay, what are you seeing here now? That's the main screen of the application. Usually our customers have several applications from CCA. That's what you're seeing on top. And you can switch between those using single sign-on. You see, I already signed on previously. You can see that over there. Our customers are usually using Active Directory to store their users. And we use the Keycloak SSO server to interface with Active Directory. And well, I have authenticated already in this case. The next thing I see is at the bottom left the current system and signal box that I am at. It says production system, but don't worry, it's not an actual customer system. I'm connected to our demo server, but each server has multiple environments. This is the production environment within the demo server. Then you're seeing a list of the previously generated written orders at this signal box. But let's delve into written order generation. I'll click on New Written Order here. And now the first question of the checklist comes up. And first thing to select is the language of the written order form. The system supports several languages. Our target languages are German and French. We just use English as the development language. I'll keep English selected for now. And the next thing I need to enter is a train reference. Let's say this is Reason Express 123. And I have to choose a situation. So these are demo checklists that we have prepared for the presentation. So these are not real checklists. Real checklists would be much more complex. And I'll pick the last situation, train departing past stop signal. Now you can see, because I selected the language and entered the train number beforehand, a preview of the written order form already appears on the right, and it's already partially filled out. I see the train number here and check mark here. I also see, if you look on the left, at the left side, on top of the card, you see 2 timestamps. The first timestamp is the timestamp the card was presented by the system. Second timestamp is the timestamp I filled it out. And this is important for the audit log. So everything, every action by the user is logged here and stored together with the written order data and can be matched against other systems later on. So the next question is train position. Where's the train currently located? I have several ways to specify that. Let me pick a location first. Now the system already knows, because of the master data that it has got, which signals are available for this location. I'll just pick one of those and confirm the card. And again, you see something happen to the form on the right. Next type of checklist card is this decision question. So you can answer yes or no, but you cannot answer immediately, because otherwise you could just go yes, 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 and quickly through all the cards, and we don't want that. So you have to arm or unlock the card first. Let me do that. The question was, does the situation result from an illegal passing of the stop signal? I say no. Now I need to know the complete path that the train is taking. I have selected the start signal first. Now I need to select the destination. And again, the system knows the paths that are available and just gives me the correct subset. Now I'm getting some more questions to confirm that everything is set correctly. If I picked no, then I might get redirected to another checklist, or the creation of the written order might be terminated, because there is no way that an instruction to continue could be produced. So let me go through these ones. Everything is stopped. Yes, we have site protection. Okay, this is another type of card that we just added in this demo checklist to see that we don't have just these yes and no cards. Here I can enter some text. So hope you enjoy this. Oh, German keyboard. Please explain why you do this. So what I just entered appeared here in the form. Please explain why I do this. Because I love Reason. Oh, well, another typo. And there's a difference between these two. This one takes a text and puts it into the form. The other one just puts it to the log. So to the audit log for later review. Now I'm getting more questions. This is related to the level crossings. So depending on the path that I have selected, there are several level crossings on that path. You can see them here in the form. They are currently crossed out because the train does not need to stop. According to what's currently selected, I say it's not secured. That was actually the last question, so I got to the next step in the written order creation process. The next step is manual editing. So the checklist, the execution of the checklist program already filled out some of the fields according to my answers. But now there are some fields where I am allowed to make manual modifications. For example, it would be these ones. So I can tick this checkbox and enter some permission number here. Or let's say these are all the modifications that I want to make, and I continue to the next step, visual verification. Well, the system tells me you made some mistake in your manual changes. This is not allowed. And again, every action must be taken manually. I ticked this checkbox, but I forgot to tick this checkbox. So the system It's not something that the system can do, should do for me. It just tells me I did that wrong, because it's my responsibility as a user to fill out the form correctly. Good, now I manage that. Click on visual verification, I have no more errors. And now you see this is taking some time, especially in Internet Explorer. This is because the form you're now seeing is not a React component anymore. It is a PNG, actually. This PNG will also be archived together with the written order data. And now everything that I entered is filled out in blue. And there's just one remaining step. That's what I mentioned previously. There needs to be an authorization number generated, and the driver's name needs to be on the form. So I'll say, OK, Mr. Driver, and issue order. And you see we have the driver's name here now and the permission number here. But what's important to note here is that we did not regenerate the PNG image from scratch, because we want to be 120% sure that the final image corresponds to what the user saw in his visual verification step, where he said that this is the correct data. So what we do is we take the previous PNG and we put the driver name and the authorization number on top of the previously generated PNG. So now we have two PNGs, and both will be archived together with the written order. Yeah, this concludes the written order generation process. I can close this now. I see there's the new order that I just generated. And it seems there is a network issue, because it says offline here. If I was online, it would be synchronized immediately to our server. Right now, it will be synchronized the next time the server is reachable again. Yeah, so this application is fully offline capable. I'm not sure if it's just our demo server that's not reachable, or if the network is totally down. It seems the network is actually down, if I look at the bottom right. But just to be sure. So where's the menu for the VM? Yeah, I wanted to turn off the network connection in the VM settings, just to demonstrate that we are really fully offline. So this is an Internet Explorer 11 application that works completely offline. I now close the browser. I guess I'm offline. I'm starting it again. All my data is back. I can fully use the functionality in the application. I can start the creation of a new written order. Let's cancel that again. And yeah, all the data will be stored locally, and as soon as I'm back online, will be synchronized to the server. So that concludes the live demo. Now I hope I can get the slides back up. Okay, well, here we are. What in it? Yeah, where's my? I'm completely confused by the. Here are my slides. Live demo, right. So to recap what we have just seen, what makes this complex application, what brings the complexity? There is a client-side interpreter for the checklist language. The application is fully offline capable. We provide full traceability of this written order creation process, so every step that the user takes is documented. We generate the PNG images and we manipulate them, so we put the two fields on top in the last step. We have Active Directory integration. We have single sign-on with our other applications. We have versioned master data in there. That is the topology data, like the paths and signals and all that, and also the checklist definitions themselves, of course. And last but not least, all of this works in Internet Explorer 11. So how did we build it? What did we use? For authentication, we use the Keycloak SSO server. There's a JavaScript adapter for Keycloak, Keycloak.js, and we created a binding for that and just using this binding. For state management, we do not have Redux or a similar state management library. We are just using ReasonReact and the ReasonReact reducer components. With the new ReasonReact that was just introduced, we could equivalently use the useReducer hook and the useEffect hook to persist the state. Would work just as well. And we do not have one global reducer, but we have one reducer that is very central to the application, and that's the reducer that manages this written order creation process that you have seen before. For persistence, we save the data to IndexedDB in the browser. We use the DEXI library, and for that we also created bindings for just the subset that we needed. The component library for the UI components, we use Material UI, and the excellent BS Material UI bindings by Jonathan, who will have a talk later today. For styling, we use BS CSS, which is a wrapper for the Glamour CSS in JS library. You have seen the application is internationalized in German, French, and English. For that, we use React Intel and the BuckleScript bindings for that, to which I also contributed. And I have created a message extraction utility that extracts the messages for localization from your Reason source code. We store the data in JSON format. We use BSJSON for that, and we write the decoder and encoder functions by hand. The image rendering is performed by HTML to canvas, and again, we created bindings for the few functions that we require. So what was the feedback that we received from our customer and also from our developers? The customer was extremely happy, both about the offline capability and also of the usability of the application. And perhaps more important, during acceptance testing, not a single bug was discovered, in spite of all the complexity that you have seen previously. And the feedback from our developers, these are actual quotes. I don't want to go back to JavaScript. And if we had done this in JavaScript, the complexity would have killed us. So what are the benefits of Reason that we noticed? Of course, the correctness and robustness that comes through static typing. Then the confidence that it gives you that most of the time, code that compiles also just works the first try, first time you run it. Regarding code size, we noticed when doing PR reviews that the PRs were much smaller for equivalent functionality compared to JavaScript. I would say about half the size. Part of that is due to the module system, which helps us get rid of all these import statements that you have to do on top of your JavaScript files. And part of this is just general conciseness of Reason. Then variance and pattern matching, they really helped us with building this interpreter for the checklist definition language. That's a really ideal use case for Reason, I would say. And we have a light toolchain with BuckleScript that compiles very fast, and the compiled code is human readable and also extremely fast or optimized. Some pain points that we noticed, the async story. Cheng mentioned this today. I think we will have to wait a bit more for some standard or officially endorsed solution. Bindings, as you have seen, we had to roll our own in many cases, and there are bindings available for a lot of libraries. Quality is different, I would say. Some excellent bindings and some in need of improvement. Then there's a consistency issue. I think that's something that cannot easily be overcome. There are just different conventions between the OCaml community and the Reason community. Although there was some April Fool's joke about automatically translating between snake case and camel case, but I'm not sure if that is feasible. There are some other pain points that we noticed last year and that have actually been resolved in the meantime. The editor integration was quite flaky at the beginning, and it works quite well now. The syntax has stabilized within the last year, and we now have a shiny new Reason React that that answers all my my requests for improvement. So in conclusion, Reason enabled us to build high-quality products with less code and in less time. And over the last year, the platform and ecosystem have matured considerably. And for us, Reason is definitely ready for production. So, thank you.